So hi guys, did you try solving problem from that exercise?
Yes,
Hopefully
sir.
limits you can solve now all problems. Is there any doubt is there in limits?
No, sir.
Are you sure you can solve all problems from limits? Sure?
No, sir.
Yeah, okay. Okay, good. So hopefully you can see the screen, right? Okay. Hmm. Where is it? Where is it? Where is it? Limits. Okay. Okay, so left hand limit, right hand limit. If both are equal, then the limit exists. If both are not equal, then the limit does not exist. Okay. So yesterday I was discussing that let's solve one of the problems. See, whenever we are solving limit x tends to 0 and sine of any trigonometric function, let's say x, when we are talking about x, so let's say x upon x, and we have written that this is equal to 1. That's what we have found out. But this x is always radian. Always radian. Okay, x is measured in radians. Understood? Got it? So x is in radian. Now if x is in radian, then how come x is in radian here? Because see here, this x is a real number, and we know radian measurement are real number measurement. Okay, radian means real number measurement. All right, that's why we do not use degree. Suppose in some problem, now let's say a problem is given, limit x tends to 0, x tends to 0, okay, sine x degrees, x degree upon x. Okay, now here this x is in degree, right? You have to eliminate that x. So this is not equal to 1. Okay, first you have to convert this degree into radian. Okay, so we know that 360 degree is equal to 2 pi radian, right? 2 pi radian, that's how we write it, isn't it? Yes or no? All right, that means x degree will be equal to how much? 2 pi upon 360 into x. These many radian. Yes? Yes or no? Anybody is having doubt here? How to convert radian degrees to radian and radian
No,
to
sir.
degree?
No, sir.
Okay, see, you don't have to write the C. Usually in books it's not written, but that's the notation we use. Okay, so first you have to replace this x. Now you will write this as limit x tends to 0. Now what is it? So sine of 2 pi, so we can write 180. So pi by 180, right? Pi by 180 x upon x. Okay, now you know how to solve it. We have already solved these type of problems, right? Where, let's say, we have solved, no, yesterday we have solved these type of problem. Yes, see this problem. Now it's a problem similar to this, isn't it? Yeah. So what we'll do here, see, there are two methods again. You can assume let pi by 180 x is equal to new variable, some variable y, t, z, whatever you want you can. Okay, so if x is tending to 0, y is also approaching 0, right? If you substitute x is equal to 0 here, you'll get y is equal to 0, right? Isn't it? So you can write same limit, you can write limit y tends to 0, sine of y upon x. Now x is what? 180 upon pi into y, right? Isn't it? Now this 180 upon pi is a constant, right? So you can again write this as, limit y tends to 0, pi by 180 into sine y divided by y. So since pi by 180 is a constant, you will take it outside of the limit. So right, pi by 180 times limit, sorry, y, my mistake, y tends to 0, sine y upon y. Now what is this equal to? This is equal to 1, right? So pi by 180 multiplied 1. So this will be equal to pi by 180. Got it? So this will be your answer. Understood? Here x is in degree. Okay, it will be written in the problem. If it's not written, that means it is in radian, and you can directly just write limit x tends to 0, sine x upon x will be equal to 1. Understood? Any doubt?
sir.
Shreya, you got it? Mitran?
Yeah.
Okay. So today we'll have the idea of derivatives. We'll study derivatives. Okay. Derivatives. See, some of the derivatives you might have done in physics, right? In mathematical tools, the first chapter, right? Who can tell me what's the idea behind derivative? What is derivative? Huh? Anyone, please? You can try.
dy by dx, sir.
Dy by dx. Okay.
Change in variable, sir.
Change in variable. Which
Delta,
variable?
sir.
Delta. Okay. Anything else? Okay. So let's try to understand the meaning of derivative. Okay, this is really important. Again, it's the why it is called differential calculus. We'll have this idea. Okay. Okay. Let's say you have your equations in physics, right? So we are again going to verify that equation. In straight line also, we have seen that for a straight line, the slope is constant, right? Right. Now let's say there is a straight line like this. So at all points, anywhere you find the slope, it will be constant, right? It's a constant slope, isn't it? Everywhere. So now it's a line, and how do we find a slope? Let's say this is some point P. Its coordinate is, let's say, x1, y1. Okay. And here we have, let's say, Q, which is x2, y2. Okay. So how do we find the slope? We find the slope is equal to rise over run. That's what we write, rise over run. Right. Now, what is rise? Rise is the change in y direction. Okay. Let's say these two meet at point S, right? So how much is PS? So that means slope is equal to PS upon QS, right? That's the meaning of slope. That's how we find slope, isn't it? Yes or no? That's how we find slope, right? Now, slope, see, at all the points we know for a straight line, the slope is constant, right? Now, how do we find a slope? If we are given the coordinate, we can find using in the coordinate geometry in straight lines, we have studied that, right? But here, let's say, now we can use PS. How do you calculate PS? PS is what? What is PS? See, what will be the coordinate of point S? Anyone? S is x1, right? Comma, what? y2, isn't it? This is the height of, this is x1 comma y2s, right? Isn't it? So slope, so you can write PS upon QS will be equal to PS. What's the length of PS? How do you calculate PS? So it is y2 minus y1, right? Upon QS is how much? How much will be QS? X2 minus x1 or x1 minus x2, whatever you want, you can write. See, x2 minus x1. That negative number we are going to ignore for a while. Now, what is y2 minus y1? It is change in y direction, right? Change in y upon change in x. That's what the meaning is. That is slope. Slope of this line. Yes? Yes or no? Anybody is having
Yes,
doubt?
sir.
Right? Now, what's the meaning of delta y? Delta y means change
Change in y, sir.
Change in y. Okay, and this is change in x. Change in x. So that's how we calculate slope for a straight line. Right? Now, you go anywhere, any point. Everywhere the slope you will find is same for a straight line. Okay? Yes? So even if you calculate slope for this part, you will find same. You calculate slope for this part, you'll find same, because slope of a straight line is constant. So because it will have only one angle, right? Slope is what? Tan theta. So it will have slope is again tan theta, right? Theta is the theta is the angle between x-axis and the line. Okay, so theta, there is only one theta. That's why slope of this line, straight line, is always same. That is tan theta. All right. So at any point on the straight line, if you find delta y upon delta x, see, this is called delta. Okay, this notation is called delta. Okay, so this will always be constant. All right. Now try to understand for a curve. Let's try to understand it for a curve. See, all functions are not straight line, right? All the functions are not straight line. We know that. This is y and x. Okay. Now let's say we have some function like this. Okay. Something like that. We have seen the graph can be anything like this, right? We don't know. So let's say it's something like this. All right. Okay. Okay. Something like that. A function is defined like this. We don't know what function it is. So let's say y, here this function is defined by f of x. Y is equal to f of x for this function. Okay, so function is defined by function of x. Now we can always calculate the average slope using the same method. Let's say we can take 2 points on the slope, 2 points. Let's say point 1 here, same point P and point Q. Okay, so if you join P and Q and you find the slope, that means you are finding the slope of the straight line PQ, right? So if you find the slope of line PQ, slope of PQ, if you'll find, that is the average slope of f of x between P and Q. Like you find average velocity, you find average acceleration, right? How do you find that? That's the way we do it, right? On the velocity time graph, if it's given, right? The slope of velocity time graph will give you what? It will give you acceleration, right? Isn't it? So if you find like say what was, say, velocity time graph, so v square. Okay, so what's the equation? V minus u is equal to at. Okay, that's the equation. And s is equal to ut plus half at square. So if you draw displacement time graph, okay, displacement time graph, the slope will give you the velocity, right? So suppose this curve, let's say some curve, it represent your this s, displacement versus time you are drawing, right? Now this curve will give you what? Wait, let's say there is a curve like this. So this is displacement time graph. So what will be the slope of this curve give? The slope of this straight line, maybe from this point to this point, this will give you average velocity. Okay, the slope of this line will give you average velocity, right? Now at any point, if you want to find the velocity, that is called instantaneous velocity. Now you see the velocity is changing at all moment, right? Here, what is this distance? This distance, how much is this? This is your ut. Okay, this is your ut from this equation. Okay, this is your ut and half at squared, because the acceleration is constant but the velocity keeps on changing. You have studied that equation in physics, right? So that's the meaning when you are finding the slope of line PQ, that means you are finding average between point P and Q of the function f of x. In mathematics, we write like that. Now, if it is displacement time graph, that means PQ, slope of PQ will give you average velocity between point P and Q. Okay, understood? Now, see, that's the average velocity, right? But we are in now if we are interested in what? Okay, let's write down the coordinate of point Q. Okay, so let's say this is point A, x is equal to A, and from A, this is x is equal to B. Let's say this is B. So what will be the value? What will be the coordinate of this point P? This will be B, comma f of B, right? Because you will substitute instead of x, you will substitute B. Here the coordinate. What will be the coordinate of Q? Anyone? Please tell me the coordinate of Q. Somebody, please tell me.
A comma f of a.
Yes, A comma f of A. Very good. Okay, it's so simple here. Why do you have to have so much of trouble? Now, if you want to write slope of line PQ, slope of PQ, that means the average slope you are finding. So slope of PQ, sorry, slope PQ. Okay, so how you will write? Change in y, that means f of B minus f of A, right, divided by B minus A. That's what we are going to write. See, again, we are going to talk about different notations. Okay, which notation is Newton's, which notation is given by Leibniz. Okay, so these are some of the mathematicians who are actually known as father of calculus. Okay, so this notation, that delta, change in f, so this is delta f of x upon delta x, right? So this notation is used by Newton. Okay, this notation was given by Newton. Now see, if you have to find at one particular point, how much is the change at this point, let's say. Okay, see, that means we have understood as of now that slope means, what was the meaning of slope? That means change in y variable with respect to change in x variable in xy plane. Right now only we are talking about xy plane. Okay, so first, if we can understand using xy plane, we can understand in other variables or other properties. All right, now suppose if you want to find the slope at one particular point, okay, how do we do that? So that means this value will start coming, P and Q will start coming closer to each other, right? So P and Q will start coming closer, yes or no? Tell me if I am wrong. So let's draw another curve for that. To understand it, let's draw it. Okay. All right. So this is y and x. Try to understand this. Derivatives, it's very easy. Means if you just want to find the differentiation, it's very easy to do that. Okay. But this idea, what's the idea behind it? Why do we use it? How is limit coming into picture? So those things will come if we can understand this thing, why we are studying limits. Okay, so again, let's say the curve, it's a similar type of curve. Okay, now let's say the gap between what I'm saying, that AB, the difference between AB is becoming very small. Okay, so AB, the difference between AB is becoming small. So what we can write, let's say this point here is A, and this point again is B, and it is coming closer to each other. Okay, both the points are coming closer. So let's say it is here, somewhat around here. Okay, B. Now the difference between A and B, let's say, is H, right? That means B is equal to A plus H, right? Yes or no? Or we can write it as, suppose, let's say, if this point is X, this point is X plus H. Okay, now what will be the coordinate of this point? So let's say this point is P, the coordinate will be X plus H, okay, comma, f of, see, this function is f or g. If you want to write g, you can write g. So let's write g. Okay, let's write g. So g of x plus h, right? And what will the coordinate of this here? Q. So let's write it here. So this is x, comma, f of x, sorry, g of x, g of x, right? Now find the slope. As see, h, you have to understand, h is really small number. h is very, very small. Okay, infinitesimal small, what we say. Okay, that's how we define h. Now if it start coming closer, that means suppose if we zoom and h is somewhat even smaller than this. See, it's not possible for me to draw on this tablet. So let's say now this is your h. Okay, this is your h, which I'm not even able to draw properly. Okay, this is your h. Got it? Now you see h is coming slow, means closer to each other. It will become a straight line. The slope will become a straight line. Can you see this? If the 2 points are here and here, very close to each other, it will be a straight line, right? Isn't it? Okay. So again, let's find the slope of PQ. Let's assume P and Q are very close to each other. So slope, let's find out slope of PQ. Let's find out. So how do we write? Rise upon run. Okay. So let's say this point is S using the same technique. So what will be this? G of x plus h minus G of x, right? G of x, yeah. So this point coordinate of this point will be what? X is x plus h and y is G of x plus h. Okay, so divided by what? X plus h minus x, right? Minus x. So this, can we write this as G of x plus h minus G of x upon h? Can we write like this? Is this correct? Yes or no? We are talking about slope of the secant line. Okay, this secant line we are talking about, and this secant line is becoming closer and closer, smaller and smaller. Okay, very small it will become. Okay, so the slope we can write. Now you see h is tending to 0, right? Now h is so small that even it will come closer. That means it will be very close to each other. H will be very close. That means h is tending to 0. Okay, that's why we are using limits here. Okay, so what we can write? Slope at a particular point, okay, on this curve at a particular point. Let's say that particular point is alpha. So slope, or let's use some usual notation. Let's say A. Okay, so slope at point A will be equal to limit x, sorry, not x, it is h, right? H is tending to 0, right? So h tends to 0, h is approaching 0, G of x plus h minus G of x upon h, right? So this is called derivative or instantaneous change. That means change at a particular point. And this is denoted by, that means you can write limit h tends to 0, okay, delta change in y upon change in x, okay, change in y upon change in x, which is also written as dy upon dx. Okay, now what's the meaning? What is the meaning here? See, we know that dy upon dx, it is called average change, right? This is in physics also, you might have studied, this is called average change, right? Average change. Now how do we calculate the instantaneous change at a particular instant, right? So how do we calculate that? So we calculate it by, you just put limit x or delta x approaching 0, okay, delta x, the change in the variable approaching 0, this is equal to your instantaneous change. So it will become dy upon dx. This is your instantaneous change. Slope or change, let's write change. Okay, instantaneous change. Understood? What's the meaning of d? See, small d represent that the change is infinitesimal small or infinitesimal. Infinitely small means infinitesimal. Okay, like you might have studied that in the relation between average velocity and average speed. average speed, average velocity and instantaneous velocity. So how do you calculate? dv upon dt is equal to limit delta t tends to 0 or approaches 0, change in velocity upon change in time. This is average acceleration, and this is your instantaneous acceleration. Understood? Is this thing clear? What is derivative?
Yes, sir.
Hopefully you might have understood the meaning of derivative, right? Okay, so we will be solving some of the problems based on derivatives. And also see the condition for a function to be differentiable. Now this is called differential calculus. Okay, now this notation, this instantaneous notation, is by Leibniz. Okay, these are Leibniz notation. Okay, so Leibniz and Newton both are, this is Newton's notation. Okay, so both are called father of calculus. Okay, Leibniz, because they both discovered at the same time. Discovered, or what you can say, yeah, discovered this. This is discovery, not an, what is that? One more thing. Okay, I'm not getting that idea. So let's go ahead and solve some of the problems. See, for a function to be differentiable, you have to understand this thing. For a function to be differentiable, it must be continuous. Okay, if the function is not continuous, it is not differentiable at that point. Okay, this is very, very important. Okay, understood? Like if we see the example of signum function, signum of x, how do we define it? This value is equal to 1 if x is greater than 1, is minus 1 if x is less than 1, and is 0 at x is equal to 0. That means if you plot this curve x, y, so this is your signum function. Sorry, it's greater than 0. Okay, 0, 0. This is your signum function. That means signum function is not continuous at x is equal to 0. That means it is not differentiable at x is equal to 0. Okay, so that's the meaning. Any curve you see, any curve which is not continuous, somehow like this, and there is a gap and starts from here, that means the function is not continuous, so it will not be differentiable. Okay, we'll see these examples. All right. So now there are certain properties of derivatives. We will write those properties, and we'll understand the algebra behind the derivative functions. Okay, so let's say f and g are two differentiable functions. That means f and g both are continuous, both are differentiable. Let's write differentiable. If a function is differentiable, that means it is continuous. Okay, so f and g both are differentiable function. So first property, write down. So differentiation of this function with respect to x of f plus or minus g will be equal to dx plus or minus d upon dx of g. Okay, d upon dx represent change in f with respect to x, change in g with respect to x. Okay, now so this is called addition rule. Okay, sum or addition, whatever you want, you can say. Next one is your product rule. Okay, so d upon dx, that means with respect to x, f into g. Okay, these two functions. So this what we'll do, we will write the first function and take the derivative of second function. All right. So first you'll treat first function like you can write like this. Okay, derivative of first function first you'll write df upon dx, and you will write the second function as it is. Okay, plus first function into derivative of second function. Understood? Now suppose if you have more than two functions, okay, d upon dx of more than two function, f, g, h, and what else, I. Let's say these are the four functions and you have to find the derivative. So what you will do, so it's very simple. First you will differentiate, you will write all three function f, g, I, differentiate the function, first function, then add all the function, and you have to take the sum of all this. Okay, we have a proof, we have the binomial proof, which I'm not going to cover here. Okay, right now the proof is not important. Let's cover up the syllabus. Okay, so g, h, I, and then see, you have differentiated f once, right? Now you will differentiate g. So write f, h, I as it is, and will differentiate g. Okay, of course, f, g, h, and I are the function of x. All right, plus now let's write f, g, I. These are product d h upon dx. Okay, plus f, g, h, di upon dx. All right, understood? Now f can be sine x. F is equal to, let's say, sine x. G can be cos x, and h, let's say it is x square, and I is equal to, let's say, log x. So that's how we are going to solve it. All right. So if you know the product rule, you can always find the what? Which rule? Divisible. Which rule? What is that called? Quotient rule. Yeah, I forgot. Quotient rule you can always find. You can always write no f into g. How you can write? Or see, d upon dx of f upon g. Okay, this you can always write no d upon dx of f into g inverse, right? G to a negative power you can use, no reciprocal you can write like that, right? So this is equal to so again you'll first keep the second function, differentiate the first function df upon dx minus first function into differentiation of second function whole divided by your second function g square. Okay, of course g is g of x, f is f of x. All right, so these are some of the rules which we are going to follow in order to find differentiation. Okay, there are other notations of differentiability, right? Like if you have the function f, okay, so f dash represents its first derivative, f double dash represents its second derivative, and so on. Okay, like if you have the displacement, let's say s is a function of displacement, is a function of time. Okay, so if you find first derivative of displacement with respect to time, you'll get velocity, right? If you find second derivative of displacement with respect to time, which is velocity, that is velocity is also a function of time, velocity with respect to time, which is equal to acceleration, which is also a function of time. Maybe if the acceleration is constant, then we will not bother about it. Okay, so these are some of the rules which we are going to see, and we'll start solving the problems. Before that we have, these are Leibniz notations, of course. Before that we are going to see a very basic theorem, okay, which is, let's say this is really important. Okay, I know you guys, you all know this one. See, this is theorem number 6 of your book. Derivative of a function f of x is equal to x to the power of n. Okay, First, we'll start solving problems based on this. So the derivative, that means f dash of x, or you can write df of x upon dx. Okay, whatever you want, you can write. This is equal to n times of x to the power of n minus 1. Okay, we have the proof using binomial theorem. Again, I told you we are not going to cover it. So just keep this in mind. Keep this in mind all the time. This is really, really important. Okay. So based on this, we are going to solve a lot of problems. Everywhere this concept is going to be used. All right. Or see, we have these many information. Let's solve problems. Okay. Question number 1 on derivatives. If y is equal to x to the power of 5, find the derivative dy upon dx is equal to what? Someone please tell me the answer.
5x to the power 4.
Yes, exactly. So this is 5x to the power of 4. Use this theorem. Okay, we are always solving problem based on this theorem first. So let's say f of x is equal to 3x square. What will be the derivative? Yes.
6x.
Yeah. See, right now here 3 is a constant, right? So we'll keep 3 outside and we will just differentiate x square. Okay, d upon dx of x square. Now this is similar to this one, the rule that we have used, right? This one. So 3 into 2 to the power of x, 2 into x to the power of 2 minus 1, that will be equal to 1. So this will be equal to 6x. All right. Okay, very good. Let's solve. F of x is equal to, or let's write down, s of y is equal to y cube minus 3y square, y cube minus 3y square plus y plus 1. Okay, find s dash of y. Now if you have any doubt, please let me know. Find out. What do you mean by s dash of y? See, you have to find the differentiation of s with respect to y. That's the meaning. So you will write ds upon dy. Okay, of course, s is a function of y. Now replace this d upon dy of sy. Sy is what? Y cube minus 3y square plus y plus 1. Now use the addition rule. What we can write this? So d upon dx of y cube minus d up, sorry, not x, I'm really sorry, this is y. We are differentiating with respect to y square plus d upon dy of y, right, plus d upon dy of 1. All right. Now what will be the first value? Tell me.
3y.
3y square. Okay. The second one. See, this is similar to this one. Okay. We are only using this rule. We are not using any other rule. We are only using this rule right now. Yes. 2y. Fine. Yes. Now the power here is what? 1. So 1 minus 1 will be what? 0. So this will be plus 1 time of y to the power of 1 minus 1, right? And here the power is what? Y to the power of 0, right? Isn't it? But we don't do like this, okay? So we don't write 0, okay, 0 into, if you want, you can write like that as well, but usually we don't do that. So 0 multiplied by y to the power of 0 minus 1. what will this become? 0. 0 into anything will be 0, right? If y is defined, unless y is infinity. Okay, so this will be equal to 3y square minus 2y plus 1, right? Isn't it? So this is the derivative of function s with respect to y. See, I have used this dash notation. You can also write this as ds of y upon dy, or you can also simply write ds upon dy. Okay, we are differentiating s with respect to y, right? See, in mathematics, usually we only use notation dy upon dx. Okay, but that is not just derivative. Okay, this is change in y with respect to change in x at a particular instant. All right. So similarly, see, you in physics you might have had problems like, okay, in motion or in force. Now force, okay, let's say acceleration. Now let's say velocity. Velocity is changing. Velocity is a function of time, and velocity is changing as t cube minus t. Okay. Now from here, what we have got, differentiation of a constant is always 0. D upon d means differentiation of a constant. Let's write differentiation of a constant is always equal to 0. Differentiation is represented like this. Okay. Now differentiation with respect to some variable. So you write d of a constant divided by any change with respect to any variable. Let's say x, y, z, whatever you want. This is also equal to 0, of course. So this is called differentiation or derivative of a constant. Derivative of a constant is always 0. Okay. Now find out derivative velocity at, now find out the acceleration. Find, this is velocity. Velocity as a function of time it is given. Find acceleration. Find acceleration at t is equal to 0 second. How you will find it? See, acceleration is what? Change of velocity. That means dv upon dt. That's what you know acceleration is. The meaning is change of velocity, because velocity is a function of time with respect to time. You can also write this as v dash of t. Okay. So with all this, let's write down. So d upon dt, change with respect to time of velocity. So t cube minus t, right? So this will become d upon dt of t cube minus d upon dt of t. So this will be 3t square minus 1, right?
Yes, sir. Yes,
Now,
sir.
yeah, acceleration is a function of time also, right? We can see that. Now you have to find acceleration at time t is equal to 0 second. So initial acceleration. So t0 will be equal to what? 3 into 0 square minus 1, that is equal to minus 1 meter per second square. That means this is retardation, right? This is in meter per second. Of course, the unit must be written. Understood? Physics, you might have had these type of problems,
Yes,
right?
sir.
You might have solved these type of problems. Okay.
Yes, sir. Yes, sir.
Okay, very good. So now let's see some of the differentiation of trigonometric functions. Okay, so differentiation of trigonometric function. Okay, so differentiation of trigonometric function. So first thing is very important to know the differentiation of the function sine x. Let's say y is equal to sine x, or you can also write this as, see, just don't write all in terms of y. Let's write y is equal to function of x, which is equal to, let's say, sine x. Okay, x is the angle here, x is in radian. Always remember x is in radian. Okay, now what is change of dy upon dx? What will be this? Or f dash of x, or you can also write y dash. Okay, you can also write df of y upon dx. Okay, which is equal to d upon dx of sine x. Okay, so the derivative of sine x is equal to what? Anybody knows that? I know you guys already know this. Tell me. Is this cos x? Huh?
Yes.
Yeah. So how do we define sine x and cos x? Why is the differentiation of sine x is equal to cos x? See, I have given you the expansion of sine x, remember? Sine x is equal to, you can write 1 minus x square, sorry, x minus x cube upon 3 factorial plus x to the power of 5 upon 5 factorial and so on. So if you differentiate it, d upon dx of sine x, see there are several methods to prove. I'm using just this method. So d upon dx of this, okay, whatever it is, x minus x cube upon 3 factorial and so on. So when you differentiate it, you'll get 1 minus 3x square upon 3 factorial plus 5x to the power 4 upon 5 factorial and so on, right? So this will be equal to 1 minus 3, and this is 3 factorial, right? So this will be equal to x square upon 2 factorial, we can write, plus x to the power of 4 upon 4 factorial, we can write, and so on. And what is this? This is equal to cos x. Okay, see, this is one of the proof. It's not like this is the only proof. This is one of the proof. All right. So similarly, so if you find the differentiation of cos x, you will get, let's say, second one, d upon dx of cos x. Okay, what is this? This will, you will get negative sine x. Okay, yes or no?
Yes.
Anybody?
Yes, sir.
Just a minute. I need to check few things if I can explain using graphs, which is not possible here. Okay, anyway. See, there is again graphical proof, which right now I am not really interested in doing that. Anyway, you can go and check it all the time. Now, what is the, let's say, differentiation of 10x? How can you find the differentiation of 10x? See, you know d upon dx, you can write sine x upon cos x, right? Now, which rule you can use? See, you can use this rule, no? df upon dg, right? Quotient rule. See, this one is the quotient rule. Where is that? This is the quotient rule, the fourth one. You can use this rule and find out the what will be the differentiation of 10x. Find out. Find out. Tell me what will be the differentiation of 10x. See, quotient rule, I'll write it here. D upon dx of f upon g. This is equal to, see, g into derivative of first function minus f into derivative of g upon g square. Find out and tell me. See, which is f and which is g here? F is sine and g is cos. So you'll write cos x into differentiation of sine x, d upon dx of sine x, minus what else? Sine x into d upon dx of cos x whole divided by cos x whole square, right? So this will be equal to cos x multiplied by, what is differentiation of sine x? Cos x, right? Minus sine x. What is differentiation of cos x? Minus sine x into minus sine x whole divided by cos square x. or you can write cos square x like this if you want. Okay, so this will become cos square x plus sine square x, right, upon cos square x. So this will be equal to what? 1 upon cos square of x. This is identity, and this is equal to 6 square x, isn't it? So the derivative d upon dx of tan x will be equal to what? 6 square x. Understood? Yes. So if in the problem you are asked to find the differentiation of tan x, you may know the answer, but you have to prove it. You can prove it like this. So similarly, your homework will be to find the differentiation of, see this is your homework. So d upon dx of cot x. Okay. Number 2, d upon dx of cosecant x, and d upon dx of sec x, secant of x. Can you find out these three? Right? Hopefully you can do this. See, we haven't studied inverse function. That's why I'm not going to give you the derivatives of inverse functions. All right. Okay. Yes or no? Are we able to understand this, or there is some doubt? Please let me know.
No, sir.
Okay. So then if you don't have doubt, solve this. See, f of x is equal to sine square x. Find the derivative. Find f dash of x. How you will use it? You can use it. You can write it like sine x.
2 cos x. 2 cos x, sir.
2 cos x. Check it again.
Wait, sir.
I want you to prove it like this. Use the product rule and prove it.
Okay, sir.
See, you can use this method also. I'll show you both methods.
Sin 2x, sir.
Sine 2x. Okay. How you did it?
It's let's take sin x as uv, sir. So u dash v plus b dash u, sir. So it's like cos x plus sin x, cos x into sin x plus cos x into sin x, which is 2 cos x into sin x, which is sin 2x, sir.
Yes. Yes. So the derivative will be understood, everyone. You can use the product rule. D upon dx of sin x into sin x. See, one rule you can use this. So you can write first function differentiation of second function into first function. So sin x upon dx, okay, plus sin x into d upon dx of sin x. Okay, so this will become sin x into cos x plus sin x into cos x, right? So this will become 2 sin x into cos x, which is equal to sin 2x, right? Now let's use this formula. We know if f is equal to x to the power of n, so from here we know f dash. See, this is the proof. Okay, we are using the second method. First, method 1, using method 2, using this formula. F dash is equal to n x to the power of n minus 1, right? Isn't it? See, why this formula is not complete, we will understand this. What's the catch behind this formula? So this is equal to, now x is equal to sin x and n is equal to 2. Okay, so f dash will become 2 times of sin x 2 minus 1, right? Sin is of course this, but we are not getting cos x, right? So where is this formula coming wrong? Why is this formula incomplete? We always use this formula, but why is it incomplete? We have to understand that part, okay, where this formula is incomplete. So let's see that. See, if a function f of x, let's write f of x is equal to n x to the power of n. So its complete derivative d f of x upon dx. We are differentiating with respect to x, right? So this, sorry. So this was correct only, right? Okay. So if this is the function, where is the formula incorrect? Let's check. So this will be equal to nx to the power of n minus 1 into differentiation of x with respect to x. Now dx upon dx is equal to 1. That's why we don't write it. Okay, that's why we just simply write nx to the power of n minus 1. Understood? That's the reason why we write it. Now suppose if f of x is a function of some other function, let's say g of x to the power of n. Okay, then how do we solve it? We will write df of x upon dx will be equal to n. Now g of x to the power of n minus 1 multiplied by differentiation of g, d upon dx of g of x. Understood? See, this is really important. Note it down. This is not there in your book, I suppose. I'm not sure. Okay, just check if it is there. It's very good. But I don't recall when I was studying if this is there or not. Okay. So this is always there. This formula is there, but I'm not sure if this formula is there. Okay. That means you have to differentiate sign again. Okay. That means d upon dx of sine x. All right. So this will become 2 sine x into cos x, which is equal to sine 2x. Got it? So inner function differentiation is also important. Okay. Understood? Yes or no?
Sir.
Let's solve one problem. So f of x, let's say some function g of x is equal to, g is a function of x, sine of cos x. Solve it. How you will solve this function? Or it's too much. I think, wait. Sine of, let's say, x square. You had solved sine square x, but let's solve sine x square. Now this is angle, right? So how you solve it? Again, as g dash of x will be equal to, I don't think this is there in the syllabus. Wait, let me check one more time. If it is not there, we are not going through it. Okay. Okay, this function has not been defined. Okay, let's leave it. But anyway, the differentiation is similar. D upon dx of sine x square. Okay, you write like this. Now first differentiate sine. So it is cos x square. Now differentiate the function x square, d upon dx. Okay, so this will be 2 times of cos x square. Understood? Yeah. So what you can do, if you have problem, you can just replace x square with some t. Okay, so you'll get, so if x square is equal to t, so g of t, g or some function, it will become h of t. Okay, this differentiation is not there. Let's leave it. I'm sorry. Let's not go through it. Solve another problem. Okay. Solve y is equal to x upon sine to the power of nx. Can we solve this? See, this is f upon g form. Let's solve this one. See, one topic is left, that is using first principle. We haven't solved any problem using first principle, that is the limit h tends to 0. That principle will solve few problems based on that. And I think the chapter is finished. Nothing more is there. Okay, so in next class, probably we are going to solve few problems, and you guys please do exercise, which one? 11.2, right? I think 11.2. Yeah. So 11.2 and this chapter is over. Which is the next chapter you guys want to do? See, next class we are going to do revision of limits and derivatives, and we'll solve, of course, the doubts if you have in limits and derivatives, of course. Okay. So which chapter next? Probability, or which chapter we have left? Vector and 3D geometry, right? Vectors and 3D, right? We haven't done, no?
So we don't have vectors.
We don't have vectors. Okay, 3D geometry is there.
Yes, sir. 3D geometry, statistics, and power.
But without doing vectors, how are we supposed to do 3D geometry? Anyway, I'll check. Okay. Okay, so please solve exercise 11.2, and whatever rules we have talked about, that is very important. This one keep in mind. Okay, you have to differentiate the inner function as well. Okay, don't just directly go and use this formula. Use this one. Okay, and of course, please solve these problems. We will solve problems on miscellaneous exercises and exercise 11.2 or 13. What is the exercise? 13. I'm sorry.
13.
Should correct me, no? Okay. So chapter 13, that means you solve all the problems. I think you'll be able to solve, except whatever is there using first principle. First principle we haven't done, but we can do it. 13.2, I think you'll be able to solve all the problems. Okay, it's not a big deal. 13.2 is really easy. And 13.3, that is the miscellaneous exercise. So we'll talk. If you have doubt, you just ask me, then only we can do it.
Yes, sir.
Okay. Okay. Thank you so much.
Yes, sir.
I'll end the class. Okay. Thanks. Bye.